two circuits contain only independent energy source. So the circuit containing only independent energy source, so in this case VTH equals to the VOC. So VTH will be the open circuit voltage across the open circuited terminal, and the RTH or ZTH will be the open circuit equivalent resistance seen across the open circuited terminal by replacing all the voltage source with their internal impedance, and all the current source are kept open. Okay. So now number 3 problem. So number 3 problem. So if you are able to calculate the open circuit voltage of this open circuit terminal, that will be the VTH. So if this open circuit voltage VOC equals to the VTH according to this rule, because this circuit contains independent energy source. Now if I take this node X and this is a node voltage Vx, and this 80 ohm resistance is connected to a open circuited terminal. Since these 80 ohm resistance are connected to open circuited terminal, that's why the current through this resistance is 0. So I80, so this is 80, so current through the 80 ohm resistance is 0, because or since this 80 ohm resistance is connected to open circuit terminal, open circuited terminal. That's why the current through this 80 ohm resistance is 0. Number 2, the voltage drop across this 80 ohm resistance must be equals to the 0. So V across the 80 ohm resistance must be 0, because I80 equals to 0. So there is no voltage drop across this 80 ohm resistance. So this node voltage VA must be equals to the Vx. So the node voltage Vx must be equals to the node voltage at VA. So node voltage at VA must be equals to the VTH. So this is the VTH, that means node voltage is VTH. That's why the Vx must be equals to VTH. Okay. Since the voltage drop, since the voltage drop across this 80 ohm resistance is equals to 0. Now if I apply, so applying KCL at node X, this is the node X. So if I apply the KCL at node X, current through this branch is along this direction. So current through this branch will be along this direction. So this current through 20 ohm resistance will be VTH minus 60 divided by 20. This is VTH minus 60 divided by 20. So current through this branch is this, and the entering node current is 20 ampere, 2 ampere, so it will be 2. So from this equation we can easily calculate that VTH equals to 40 plus 60, that means 100 volt. So VTH is 100 volt. Okay, so now you have to calculate the RTH. What is the RTH? RTH is the equivalent resistance seen across this terminal by replacing the voltage source with their internal impedance, and current source are kept open. So if I arrange this circuit, so it will be look like this. So this is A, this is B. So this is 80 ohms, 80 ohms, and this is 40 ohms, 40 ohms, and this is a current source, and this is another 20 ohms, and this is a voltage source. So voltage source, the voltage source will be replaced by their internal impedance. Since this voltage source has zero internal impedance, that's why it is short circuited. Okay, and current source are open circuited. Okay, OC, open circuited. So you have to calculate the R equivalent from this point AB must be equals to the RTH. So R equivalent equals to RTH equals to 80. This resistance are in series, so 80 plus 20, and this resistance is not included in calculation of this RTH because this is open circuited terminal, so there is no current flow through this resistance 40 ohms. That's why this resistance is not included in this case. So it will be 100 ohms. So RTH is 100 ohms. So this is the problem number 3. In previous class I have solved 2 problems. Okay, and there is another 2 problem. Now problem number 4. Problem number 4, you have to calculate the open circuit voltage across this terminal. That will be the VTH. So if you want to calculate the open circuit voltage across this terminal AB, and that will be the VTH, so in this case you have to calculate this current through this branch, that means 6 ohm. If you are able to calculate current through this 6 ohm resistance, then you will be able to calculate VOC equals to the current through this branch multiplied by 6. So first of all you have to calculate the current through this branch. So suppose this is current from this voltage source is I1. So this current will divide it in 2 paths. Suppose this along this direction I2, so this will be I2 and this will be I2. So current through this branch, it will be I1 minus I2. So current through this 2 ohm resistance, it will be I1. Okay, so if I take, this is a one mesh, this is mesh number 1, and if I take, this is another mesh, this is mesh number 2. Now our aim is to calculate this I2. So applying KVL at mesh 1, this mesh. So if I start from this point, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus, this is minus, this is plus. So from this point, from this, it will be 2 multiplied by I1, this is plus minus, this is plus minus, plus I1 minus I2 multiplied by 6, I1 minus I2 multiplied by 6, and this is 2 multiplied by I1 minus 12 equals to 0. So plus minus, this will be I1 into 2, this is plus minus I1 minus I2 into 6, and this is plus minus I1 into 2, and this is minus plus, that's why minus 12. So from this equation you can calculate that this is 2, this is 2, so this will be 4 and this is 6, so this is 10 I1 and it will be 6 I2 minus 6 I2 equals to 12. Okay, this is 6, 10 I1 plus 6 I2 equals to 12. So this is the equation number 1. Now similarly applying KVL at mesh number 2. This is mesh number 2. So if I start from this point, plus minus, this is plus minus, this is minus plus. So this is I2. So I2 multiplied by 2, this, and this I2 multiplied by 6 plus this is I2 multiplied by 2, and this is minus, this is plus, so it will be minus I1 I2 into 6 equals to 0. So from this point you can calculate that this is only I1, so this is minus 6 I1, this is 2, 6, 8, 10, and this is plus 6, so it will be plus 16 I2 equals to 0. This is equation number 2. So from these two equations you have to solve the value of I2. So if I multiply this equation by 3 and this is multiplied by 5, then I will get this is 30 I1 and this is minus 18 I2 and this is will be 36 18 and this is 30. Now from this equation if I multiply by 5, so it will be minus 30 I1 and this is plus this is I2 equals to 0. So here this will be cancel out, so here it will be 2 and this will be 62 I2 equals to 36. So I2 will be 36 divided by 62, so it will be 18 divided by 31. This is ampere. Okay, so current through this 6 ohm resistance is 18 by 31. Now how to calculate the VTH? So VTH equals to the VOC, open circuit voltage. So voltage across this 6 ohm resistance, so it will be I2 multiplied by 6, I2 multiplied by 6. Here is I2 is 18 divided by 31 multiplied by 6, so it will be 108 divided by 30 volt. Okay, so VTH is this. So in this way you can easily calculate the VTH of this circuit. Now you have to calculate the RTH. So how to calculate RTH? The equivalent resistance seen across this terminal by replacing the voltage source with their internal impedance. So this circuit can be arranged in this way. So this is A, this is B, this is 2, this is 2, and this is voltage source. This is 2, this is 2, okay, and this is 6, and this is 6. So this is 6 ohm, this is 6 ohm, this is 2 ohm, this is 2 ohm, and this is also 2 ohm, this is 2 ohm, and this is voltage source. So voltage source is to be short circuited. Okay, so the RTH will be the equivalent resistance seen across this terminal. So what will be this equivalent resistance from these 2 points? So R equivalent equals to the 6 parallel to this 2 plus 2, 2 plus 2. From this point, if I look this circuit from this point, so this equivalent resistance seen across this point, it will be 6 parallel to 2 plus 2. This because this is are in series, so it will be 6 multiplied by 4, so it will be 2.4. Now RTH will be 6 parallel to 2 plus this equivalent 2.4 plus 2. This resistance parallel to 2 plus 2.4 plus 2. So in this case it will be 6 multiplied by 6.4 plus 6 plus 6.4. So it will be 6 multiplied by 6.4 divided by 12.4. So if you, this is 3, this is 6, this point is 6, 2, okay, 6, 2. So it will be 3, 1, this is with 3, 2. So it will be 696 divided by 30 ohms. Okay, so this is the RTH. So in this way you can calculate the VTH and RTH of a circuit. In the next class